Now, in the last lesson, we spoke about the theory part of structs versus classes, and we talked about value types versus reference types. Now, in this lesson, I want to show you using real-life examples just what all of that means. So we're going to create a new project inside Xcode so that we don't mess up our calculator app. And you're going to head into the Mac tab and choose the command line tool and go ahead and click next. Now I'm going to call this simply just structs versus classes, and I'm going to save this somewhere on my desktop. So we've worked with Mac command line tools before, and you know that there is a main.swift, which is the entry point, and all of the code here gets called in sequential order. And this kind of structure allows us to create multiple files that we can tap into, so I can show you the differences between structs and classes. Now, I'm firstly going to delete that print statement, and I'm going to create a brand new Swift file inside the same folder, and it's going to be called class example. Then I'm also going to create something called struct example. And now I have my two files where I will show you what structs and classes do. So now we can head over to our class example, and we're going to create a brand new class. Now this class is going to be called superhero, and it does not inherit from any other superclasses. It's just an independent class. Now this class superhero is going to have two properties. One is going to be called name, and it's going to be a string. And the other is the universe where the superhero is from. And this is also going to be a string. Now, at this point, we're pretty used to this error, which says class superhero has no initializers. Our two stored properties, name and universe, both don't have any initial values. And Swift, remember, always needs initial values, even if it has to be nil. So in this case, I'm not turning any of these into nil by turning this into an optional string. No, I'm actually going to initialize it. So to initialize it, we can write the designated init. And in this init, so whenever we try to create a new object from the superhero class, we're going to provide a name that's in the form of a string and the universe in the form of a string. Now, when we initialize the class with those values, then we're going to set this class's name property to equal that local name variable. And we're going to do the same with our universe. Now, all of this should be familiar to you, because in the intermediate Swift classes, we spoke about designated initializers, convenience initializers, and what it means to create new objects from classes. So if you need a brief refresher, feel free to head over there and just revise those sections before you come back, because I'm going to assume that you've understood how to initialize a class. So now that we've created our class, then we can quite easily, in another file, create our object from that class. So let's create a constant called hero, and it's going to be equal to a new instance of superhero. And when I try to initialize it, you can see that the initializer requires that I give those two stored properties a value. So let's call it, I don't know, Iron Man, and he's from the Marvel universe. Okay, so this is how I've created my class. And this is how I've initialized my object from that class. Now, if I was to go into my struct example and create that superhero class as a struct instead, then I would simply replace the word class with struct. And the struct also has to have a name that's capitalized. Now, if I try to call this superhero as well, then you can see that Xcode gives me an error, and it says invalid redeclaration of superhero. Now, even though in this case this is a superhero struct, and in this case this is a superhero class, the Swift compiler doesn't actually let you give the same name to structs, classes, or enums. So I can't create an enum called superhero either. this is all forbidden. So I have to give it unique names. So let's change our class superhero to be called class hero. And of course, we have to change it here as well. And then inside our struct, I'm going to call this a struct hero. And now all of our errors will go away and we can continue creating struct hero. So again, this struct is going to have two properties, name, which is a string, and also universe, which is also going to be a string. Now, in this case, you'll notice that no matter how much I try to refresh or Command B or run, you can see that I don't get any errors, even though I also don't have any initializers inside my struct. Whereas with our class, if I didn't have these few lines of code, then Xcode very quickly starts screaming that class hero has no initializers because these two stored properties need values and therefore I need an initializer. Well, in structs, you actually get a free initializer. So down here, if I try to create a new hero that's a new instance of the struct hero, you can see that as soon as I try to initialize it, I get an initializer. And this is created behind the scenes every single time you create a struct, which makes life just a little bit easier for you when you're creating these structures. So now that we've seen how you can initialize structs and classes, I'm going to delete these two lines of code. And we're going to head into our main.swift. Now over here, I'm going to create a new hero, which is going to be a class hero. And I'm going to initialize it as Iron Man from the Marvel Universe. Now at this point, if I needed another Marvel hero, then it might seem that I could just say another Marvel hero is equal to hero. And I make a copy of this hero, which is initialized to have Iron Man as the name and Marvel as the universe. And then all I do is I change my another Marvel hero and I only change its name and I call it the Hulk. Now, because our hero already has Marvel set as the universe, then my another Marvel hero, just by copying over that hero, then it seems like I would have that same universe already. And all I need to do was just to change its name. Now, if we go ahead and do some print statements just to see what those values are. So let's say hero name equals, and we'll use string interpolation to tap into hero.name. And we'll also at the same time print another Marvel hero name is equal to another Marvel hero dot name. So let's go ahead and run this. And I want you to predict what will be the result for each of these print statements. All right, so that is the result that we got back. We've got hero name equals the Hulk. Another Marvel hero name equals the Hulk. Wait a minute, there has to be something that's wrong here, right? I didn't change the name for hero. I never said hero.name equals the Hulk. What is this all about? This is not what I predicted at all. Well, this is a good example of a reference type behavior. Now, when I made a copy of hero and I assigned that copy to something called another Marvel hero, what actually happened behind the scenes is I simply created a new reference to the same object. And when I changed a property on my new reference, it also changed the property of that same object, which both another Marvel hero and hero refers to. Now, remember how we said that structs were value types and classes were reference types? And when I create a new copy of a struct, I just copy over the values to a new thing. But when I copy a reference type, then I simply create a new reference to the same thing. And the actual object is not copied at all. There's still only one blue folder that contains all of that data. So whereas with structs, when we make a new copy of the struct, we end up with two copies, each having separate values that can be changed separately from each other. But when we copy reference types, such as classes, then what we end up doing is we don't actually copy the object with all the data. We just copy the reference to the object. And this means that we now have two references to the same object. And when we try to change hero or when we try to change another Marvel hero, they're both changing the same thing. And it can get very confusing very quickly. You can imagine that as your app gets more complex, you can end up with objects that are referenced from lots of different places, all trying to modify the same object. And you will end up with really unexpected behavior. And you will lose track of which reference is changing which object and end up with a whole lot of complexity and an app that's very difficult to debug. Now, whenever I think about this problem of multiple references to the same object, I think about Black Friday sales and people fighting each other for the same objects, all trying to grab it and buy it. And as you can see, there's a lot of mayhem that ensues. So if we head back into our code, where we showed that unpredictable behavior previously, where by changing another Marvel hero's name, we actually ended up changing the original hero's name as well. Well, let's go ahead and change this hero from a class hero to a struct hero using our struct blueprint in the struct example file. Well, now, when we create a copy of the hero that's called another Marvel hero, when we change the name of another Marvel hero to the Hulk, it won't affect our original hero struct. So let me press play and show you what the results look like. You can see that our hero name is Iron Man, just as we intended, and our another Marvel hero name is the Hulk, just as we intended as well. And this is why structs are much simpler, which means that it's easier to create a larger app with less complexity. And you can imagine that if you're coding on the same project with lots of different people, or sometimes even if I code with me and me in 6 months, me in 6 months is like a random person. She doesn't remember how the code works. She doesn't remember which things can be changed, which things shouldn't be changed, what the effects are. And so we have to safeguard against all of that. We have to try and make everything as least error prone as possible so that you guard against other people or future you messing up your code. Now here's another example of when reference types can really hurt you. Let's say that I create a new hero initialized from our class hero again, and I create a new array called Avengers. Now inside my array, I'm going to include my first hero as well as my another Marvel hero. So now I have an array with 2 class hero objects. And at some point I realized that actually my Avengers, I'd really prefer the first Avenger to be Thor instead. So I know that I've created this brand new Avengers array with some heroes inside, but I'm going to change that array's first item to have a different name and call it Thor. So now if I go ahead and print my first Avenger name, now what do you expect to happen? Did you expect that all 3 heroes now all have the name Thor? Or did you expect that we'd be changing the actual array rather than all of the referenced objects? Well, in this case, our Avengers, it's actually an array of references. And whenever we change anything about our array, we're actually not changing the array. We're changing the underlying object, which is shared between this array, this object, and this object. And so now all 3 of them have the name Thor. Now, again, we can fix this by simply reverting back to a simple struct. And in this case, everything that we assumed is now exactly what happens. Our hero is still called Iron Man. Our another Marvel hero is now called the Hulk. And our first Avengers name is now Thor. And this is one of the biggest benefits of structs. They make everything a lot more predictable, a lot simpler. Instead of having these references all over the place pointing to different objects that sometimes might collide, and you might have a different class that changes your object without you expecting it to. Well, with structs, it's a lot more straightforward and it's a lot simpler. Now, another problem with class objects is how they deal with immutability. So I'm going to delete all of this code other than our initialization code. and I'm going to create a new instance of a class hero. But instead of creating it as a variable, I'm going to create it as a constant. So now I have this constant, which is called hero, which is of type class hero. Now, what do you think will happen when I try to change the name property of my constant hero? So we all know that constants get a value assigned only once and they cannot be changed, right? Well, then why is it possible to do this? And I'm not getting any errors at all from Xcode. This is perfectly legal to do. Well, the reason is because in our class hero class, you can see that we created name and universe as properties that are variables. And this means that even though we create a constant called hero, the only part of it that's constant is that we can't simply reassign it to a new class hero object. We can't do this, right? This is what the let is preventing us from doing. But it does let us change everything else about our object hero. I can change the name, I can change the universe. Now, that's not right? Now, the whole reason why we create things as constants is to make it immutable. Make sure that the future me or somebody else on my team can't accidentally change something that shouldn't be changed, right? So this is another reason why you might use structs. Because if this was a struct instead, then we will get true immutability. And you can see that Xcode now gets angry even when we try to change one of its properties, because hero is a constant now and it has true immutability. It cannot be changed after it was created because it has that let keyword and also because the underlying thing is a struct. And this is because a struct, remember, is a value type. So when you change it, you actually have to create a whole new copy. And that let keyword is not letting us do that. So none of it can be changed if it is declared as a let constant, which is again kind of what you would expect, right? When you make something immutable. The previous behavior, when we were able to change lots of things about our hero without any warnings at all, can potentially lead to a lot of unexpected errors. Now, the last thing I want to show you about structs is if inside our struct, we created a function and it's called reverse name. And this function returns a string. And what it does is it takes the name, so self.name, and it calls the function reverse. And what this does is it will return an array containing the elements of this sequence in reverse order. So that means that if our name was Hulk, then what we'll get back is KLUH. But the only problem is that this returns a collection, a reversed collection, and it's not a string. So we have to cast it into a string if we want to be able to return this as a string. So now if we head over to main.swift and we say hero.reverse name, and let's go ahead and print the output of this function call into our debug. And you can see we get Namnori, which is the reverse of Iron Man. Now, so far so good. But what if our method inside our struct was trying to change one of its properties instead? So let's get rid of this output and make this function rename self.name to equal self.name reversed. Now, when you try to change a property inside a struct, Xcode will give you an error. And this is because whenever you try to change a structure, you have to create a new copy. And so if your method is going to change something about the structure, say one of its properties, to have a different value, then we have to mark this function that has that capability with the keyword mutating. And this tells the Swift compiler that, hey, watch out, this method is capable of changing the structure. So that means that when this method is run, we need to create a brand new copy of this structure. And this is why you see this keyword mutating all over the place when you start working with structs. So structs are really, really cool. And they're very, very useful. And they're simple things that are predictable, which will make your code less prone to errors and to bugs. So I recommend that whenever you're creating a new data model, to go for a struct instead of a class if you want to create a better architecture for your app. Now, there is just one thing that structs can't do, and you have to be aware of. They can't subclass. So, for example, if I wanted to create a struct that was a subclass of NSObject, for example, then I will get an error. Non-class type struct hero cannot inherit from class NSObject. You don't get inheritance from structs. If you need inheritance, you have to make a class. And this also means that when you're working with Objective-C objects and you want to be able to subclass them or work with them, then you also can't use structs, because in Objective-C, the structs are very different to the Swift structs. The structs in Swift is almost like an 8-legged insect, whereas the struct in Objective-C is kind of like an insect with just one leg left. It doesn't really do very much. So what you should remember from this lesson is that a struct is a value type, and that means that it's copied whenever it's used. So it's equivalent to, say, if we were working on a presentation together, and we've got a template that we're working off. I give you one copy of the template presentation, and I have one copy of the template presentation. We work on it alone and independently at home, and that means that my edits to that copy will not affect your copy, and vice versa. Now, if we were working with classes instead, because classes are a reference type, then whenever they're passed around or whenever they're used, say inside an array or passed as an argument in a function, whenever you try to use a class object, then you're creating a new reference to it. And when you edit it or when you change it, you're always changing the same underlying object. And this is equivalent to us working on a presentation together, and we've only got one printed copy. So that means that if you decide to scribble a mustache over my headshot in the presentation, well, that is what we're going to present at the end. All of your changes affect mine because we're all referencing the same object. So in terms of the differences between structs and classes, structs are simpler. They are faster because they're stored in the stack rather than the heap. And you can create deep copies of structs that are not just references to an object. They have true immutability. So when you declare a struct as a let, then you can't change any part of the struct, including its properties and methods. And finally, you have less memory leaks and thread safety as well, which we're going to go into when we explore more topics such as memory management and multi-threading. Now, in comparison, classes, they have inheritance, and this is the biggest thing that's going for them, because inheritance is core to object-oriented programming. Being able to inherit and subclass is what makes OOP so powerful. So when you need inheritance, then you'll need to use classes. And also, classes will allow you to work with Objective-C code. And a lot of the API for the iPhone is still in Objective-C. So when you need those components that are written in Objective-C, then you can't interact with them using a struct. So the official Apple advice, which was updated only a few weeks ago, and this is apparently their final word on this topic, is that you should use a struct by default whenever you want to create a new custom object, and only turn it into a class when you find that you actually need inheritance or you actually need to be able to work with Objective-C code. And then in that case, turn the struct into a class. So in certain cases, you still need to rely on classes, but start with a struct and only go up if needed. This is exactly the same as the advice for Swift access levels. Start with the least inclusive, most private access level and only increase its capability as and when needed.